It's great to welcome to the program today for what I think will be a really great conversation. Lee McIntyre, who's a research fellow at the Center for Philosophy and History of Science at Boston University. He's the author of the new book, The Scientific Attitude, Defending Science from Denial, Fraud, and Pseudoscience. Lee, so great to talk to you today.
Great. Thanks for having me on. I appreciate it.
So, to get the audience sort of acclimated to what we're going to be talking about, in the book, you outline that there is a sort of denial and a resistance to science as an institution, sort of above and beyond specific topics, which we can get into in more detail later, that really needs to be met head on. And you actually propose in the book exactly how that should be done. Let's first make the case that this is an issue. I mean, for someone in the audience who is skeptical that there is this anti-science movement, how can we explain to them that this exists?
Well, I think it's a great question. And I mean, what you have to do is to pay attention to the fact that the anti-science or the science denial happens in many different areas. Anti-vax, climate change denial, flat Earth is on the rise. People who deny evolution by natural selection. If you look at any one individual case of that, you might think, well, it's only a few people. But cumulatively, what you realize is that the standard of reasoning around scientific issues has really eroded in this country and that science denial is on the rise.
One of the things I've suggested, and I'm sort of open to it being right or wrong or partially right, is that if you look at anti-intellectualism and pseudo-intellectualism, that pseudo-intellectualism may actually pose a bigger danger in the sense that
Yeah.
it's the difference between those who say, I don't think X really matters at all, versus those who say, I've looked at a little bit about this. I've read maybe in the world of politics, for example, I've read some of those pop politics books by people like Laura Ingraham and Tucker Carlson, and therefore I now am as informed as anybody else. My instinct has been that the latter, the pseudo-intellectualism, can actually be more dangerous within the context of science. Where do you think that the truth is on that?
I think you're absolutely right. One thing that happens is a lot of people these days have a degree from the University of Google, right? They get on the internet and they find something and they don't know whether it's reliable or not. But after Googling around or hearing someone speak, they think that they know the facts. And empirical evidence has actually shown that it's much harder to convince somebody who knows a little bit about a topic than somebody who doesn't know anything. I mean, that goes back to Socrates, who said that ignorance was not as dangerous as false knowledge. You know, the people who think that they have the right arguments, they're just not willing to listen anymore. So I think you're dead on with that.
Is this problem in the realm of science, science skepticism, so to speak, is it worse in the United States than in other sort of, I guess we could say, other countries in general, but maybe specifically worse than in other Western, wealthier countries?
Well, I mean, we're number one for a lot of these. There are actually rankings on science denial for some specific areas. It turns out that we're number two for denial of evolution by natural selection. The country of Turkey is worse than us. They actually ban teaching evolution in their public schools. But we are definitely number one for climate change denial. Interesting thing about that, based on the recent survey, is that China turns out to be the most enlightened nation in the world on the subject of climate change denial, and they're the worst polluter. So that's really kind of an interesting thing, and I think shows you that it's not just about politics, it's about reasoning strategy.
When you look at the flat earth movement in the United States, and there's debate over how much of that movement is sort of satirical in nature, but at least some significant portion of it is not satirical. There's really no way to deny that.
That's right.
What do you make of the growth of that movement?
Well, I don't know if you know this, but I went to the Flat Earth Convention in Denver in November of 2018.
Yeah.
And there were 600 Flat Earth folks there and me. And the first day I went incognito. I mean, I bought the badge and I went because I study science denial and I wanted to see what was up. And I'm here to tell you, they were serious. They were not, it was not satirical. There were true believers aplenty. There were seminars, how to recruit new folks for Flat Earth. And it's a growing, rising movement. I think within 10 or 15 years, there are going to be flat earthers running for school board and trying to get us to, quote unquote, teach the controversy in the public schools. same way that they're now doing for climate change, same way that happened a decade or more ago with evolution by natural selection. It's a growing movement, but they are absolutely dead serious about this. They think that they know the truth, and the rest of us have been brainwashed.
One of the things that I've experienced myself when talking, either it could be to flat earthers, could be to vaccine deniers, it doesn't really matter who, is that you often start the conversation about the merits of the particular subject. Like it's a conversation
Mhm.
about flat earth versus spherical earth, for example. But then at a certain point, it gets into the more general distrust or that comes from a misunderstanding of what science is and the scientific method. There's often this idea that, listen, science has been wrong. The conclusions of science have been wrong in the
Yeah,
past. Therefore, science as a process is what is problematic. How can you start to unwind that part? Because if
yeah,
you don't unwind that, you can't even really talk about the subject matter.
yeah. Another good point. I mean, the the way to handle something like that is to make sure that you're not buying into one of the myths of science. And I
Hmm.
think that one of the myths of science that a lot of science deniers buy is that science has to prove something, that science is about certainty. And in actual fact, science, that's just not the way that science works. Anytime you're trying to gather empirical knowledge, you always have the idea that, maybe your study can be overthrown by some future data. But what people fail to realize is that's not a weakness of science. That's a strength, the being able to deal with and even learn from uncertainty. What happens with folks who are not scientists, or who I'll say who don't want to believe in science, is that they take uncertainty as a weakness and an opportunity to exploit for their own views. I think that this idea about science embracing uncertainty is really something that's endemic, and it has been for a long time. What happened recently, though, is that people have stopped trusting experts about a number of things. There's a terrific book by Tom Nichols called The Death of Expertise, where he talks about this. It's not just for science, it's for many different things. But the effect in science is that if people don't understand something that a scientist says, they'll say, well, what do you know? I'll go look it up on Google.
Yeah, and I think that the problem with a lot of that is, so on the one hand, I'm familiar with the book and it brilliantly points out what you're talking about. The other
Mhm.
problem is that there is this thing called the media expert industrial complex, for lack of a better term, where
Yeah,
people who are just kind of like partisan political actors
yeah,
are regularly interviewed in media as experts when they're not. So it's sort of like people are right to be skeptical of individuals identified as experts in some ways, but on the other hand, it's having this very detrimental effect within the field of science, and I don't know how we deal with that problem.
it is a real problem, because if you look at the way that scientific issues are covered in the media, and I have to say especially on television, they often engage in false equivalence because it's so easy to have a split screen. They'll have somebody from NASA on one side, somebody with a website on the other. They'll give them equal time, and then at the end say, "Well, it's a controversial issue. You decide." Turning to the audience, that's not the way to present scientific issues. They often, the media, because they're looking for an angle, they want to stir controversy where there isn't one, which was disastrous for anti-vax. I mean, look at what the trouble that we're having now, and it's because of all the media attention pretending that there was a controversy where there's really not. I think the same thing happened with climate change. It's really irresponsible to have that sort of false equivalence. Happens all the time in the political arena with predictable results. When it happens with science, I think you face a real problem, because the halfway point between the truth and a lie is still a lie.
Can we talk a little bit about what methods you think are effective to kind of disabuse people of these false notions, either about
Yeah,
science in general or about particular issues if you want? And the way I would sort of frame it is, we know that as a general kind of behavioral economics, cognitive psychology, sort of rule or understanding, that just giving people contradictory facts to what they believe
hmm,
usually backfires. It often has the effect of making people just seek
yeah,
out more confirmatory evidence for what they already believe. The measles outbreaks is an interesting one, where one might imagine, well, hold on. In growing anti-vaccine communities, there is a growing problem with measles outbreaks. You would think that that would get people to re-examine their beliefs, but it doesn't really seem to work this way.
Well, it can, and I mean, there were great studies on this and the backfire effect. And yes, if you just ram evidence down people's throat, but they're not willing to hear it, then you've got a problem. But there is some other experimental evidence, some studies which have shown that that's precisely what you should do. You should make sure that people hear the facts. Now, the context in which they hear the facts is important. If you make people feel stupid or you yell at them, then they're much less inclined to believe you. But for instance, in the way that they're handling the measles outbreak in Washington state, they're having workshops. They're sending public health officials and physicians out to talk to people one on one or in small groups, and that seems to be working. I mean, it's what I tried to model when I went to the Flat Earth Convention. I wasn't just trying to learn from them; I was trying to convince them. And I can't say that I convinced anybody, but I went in with this idea: you convince people by listening to what they have to say, treating them with respect, and then gently showing them where they're wrong. Just if they're willing to engage in actual debate, you should do that. One problem I think is that people have underestimated the growth of science denial, and scientists in particular are not willing to have these debates. They walk away from these debates. And meanwhile, science denial is growing and growing, and it's now at the level of the Senate or even the White House, and we've got a real problem on our hands.
Yeah, that's one of the things we've talked about on my program for a while, and people will regularly call in and they'll talk about, not in this particular context, but for example, with the challenging, dangerous, extremist ideas. When is it worth ignoring them versus when is it worth actually having
Yeah.
conversations and pushing back? And I don't know that in the political space, there's a one size fits all answer. What I've said is when my assessment is that the ideas are prevalent enough that left unchecked, they could grow
Yeah.
out of control. I want to make an effort to challenge those ideas, but I don't know how you make that calculus on the science side.
It's tough. I mean, if you're having a values debate, you probably can't convince somebody. You'd like to think that if it were an empirical debate, that eventually people will, that you could make some progress on something like this. And so, I mean, it is probably more difficult in the political arena than it is in the empirical arena. But I mean, you do find people in the empirical arena changing their mind. I remember the story a few years back of the mayor of Coral Gables, Florida, who is a staunch Republican. 4 days into his mayorship, changed his mind on climate change, and it was because he saw the reality of what he was dealing with. So it's very hard to change people's mind, but I think it's almost impossible unless you engage them in debate and try to control the terms of the debate. That is, make it about facts. Or I'll tell you one question that I used with great effect at the Flat Earth Convention. What evidence would it take to convince you that you were wrong?
Yes, the defeasibility test, which I was first
Right.
introduced to by Peter Boghossian, actually, but I know is
Yep.
something that's been around for a while.
Yeah.
Very very effective in my experience as well.
It stopped them. They couldn't really answer it. I'm not sure how much ground I made on it, but it stopped them in their tracks because I don't think they'd ever heard that question before.
We've been speaking, at least in part, about what's in the great book by Lee McIntyre, The Scientific Attitude, Defending Science from Denial, Fraud, and Pseudoscience. Lee, really a pleasure having you on.
Thank you so much. I really enjoyed it.